Fine. So what we are going to see today, we are going to see multiple linear regression. So multiple linear regression means we will have one dependent variable and multiple independent variables. Okay. So here today the data set what we are going to work. So we are taking a sample data set, a synthetic data set. We are taking a dictionary and we are creating that one into a data frame. What we are going to see today is to predict the score based upon the overs played by the team, wickets lost by the team, runs made by the team in that particular overs, depend upon the run rate and whether the team is batting first or bowling. Okay, so based upon these things, what are these overs, wickets, runs, run rate, batting team, and bowling team? These are independent variables. Fine. So the score depends upon the wickets fall. The score depends upon the run rate. The score depends whether we are batting first or bowling first. So this example we are going to take today and we are going to complete one. So for that first what we are doing, we are importing certain libraries. So always it is mandatory to import libraries. So what are the different libraries we are importing? We are importing NumPy as NP to work with NumPy and Pandas as PD. So to work with the data frame, so we are importing this library Pandas and sklearn. So sklearn means scikit-learn. So we are importing training, test, split, and all because we split the data into training, into testing data. So X train, Y train, and all those things. Next, from sklearn matrix, we are importing mean squared error and R squared score. So I told you what is this mean squared error is. So predicted values versus actual values, the difference is nothing but the square of the difference is nothing but the mean squared error. So let me run these libraries. We had run that libraries and then let us take this data. So data. So these are overs, wickets, and also if you see, if you observe what is this data is nothing but it is a dictionary. Okay. So in the dictionary, we have overs as the key and the list of overs, wickets as the key and a list of wickets as the values, and then runs as a key and list of runs as a value. So run rate and so on. So let me run this data. Run that one and come here. So what I'm doing, I'm converting this data into a data frame. So df equal to pd dot data frame, it will do that particular work. So now convert that one into a data frame. Run it. So this is df data frame. So wickets, runs, run rate, batting team, bowling team, and we have score here. So what is the thing we have to do? The moment we have a data set, a data frame. So what we have to do? We have to separate the independent variables and dependent variables. So score is a dependent variable. And if you see rest of the things, so overs, wickets, okay, runs, run rate, bowling team, these are independent variables. So now let us separate the dependent variable and independent variable from this data frame. So come here. So df x and y, I'm separating independent variable and dependent variable. So on that one, so we had separated, see this is x. X consists of independent variables, overs, wickets, runs, run rate, batting, and then we have something called as ball. Okay, so these are independent variables. And if you see y, so what is y? Y is the dependent variable. What is that score? We have various scores over here. So once we separate the independent variables and dependent variables, what we have to do? We have to split the data into training and testing. So what size we are doing? Okay, so if you see here, we are taking this Its test size equal to 0. Okay. So what is the meaning of test size equal to 0.2? So that means we are taking 20% of the data into testing data and 80% of the data into testing training data. So always we what we do is we split this data in such a way. So this is the data, guys. So this data, what we are going to do. So we have 10 records over here, 8 records. We are going to do training on 8 records of independent variables, that is X, and 8 records of Y. And 2 records, what we are going to do, we are going to take as testing records. So that is what this test size. Okay, so that is what this test size equal to 0.2 is doing. So then let us split the data and let us see what will happen. Okay, X train, X test, Y train, Y test. Let me run that one. So this is X train. So if you observe, 8 records has taken as the training data, X training. And if you check Y train, so 8 records of independent variables is taken as Y train and X test. So 2 records has been taken as X test and let us take Y test. So 2 records has been taken as Y test. So what are we actually doing? Why we are splitting this data? So we are splitting this data in such a way that 80% of the data, what we are doing, we are training the model on 80% of the data and we are testing the model with the 20% of the data, whether we are reaching the predictions or not. That is what we are doing. So 80% of the data is taken as the testing data, training data. We are training our model with 80% of the training data. And 20% of the data we are taking as for the testing purpose. How good, how accuracy, or in order to calculate this mean square errors and other things, we are doing that particular thing. Okay. So now, if you see here, we have one more piece of code. What is that piece of code? Random state equal to 42. Okay. So what is this random state equal to 42 is doing? So this random state equal to 42, what it will do is it will, the training and test split randomly chooses training and test rows. Okay. So when we set as random underscore state equal to 42, so this means if we run the program multiple times, we get the same training and split data. So if we run the program multiple times, we'll get the same training and test split. So why we have to fix this one? The reason is if the model every time if it gets trained on a different training data and testing with a different training testing data. So our mean square will change or R score will change and so many things may happen. That is the reason why we need to fix them. For example, if you see here, if you check X train, so let me take X test. See, this eighth record and first record are used. Eighth index record and first index record are used X test. Suppose Y test. So again 8 and 1. Okay. So now I am running this one again. Let me split and run it again. I am running it again. So now a different training and testing. It is running again and it is generating again. Now check again next test. The same records 8 and 1 are taken. Now check Y test. The same records 8 and 1 are taken. Okay. So every time when we run, the same split will happen. Okay. So that is the reason why we take this particular concept. Okay. Next thing, come here. Now I'm creating a multiple linear regression model. So model equal to linear regression. There. Model equal to linear regression. So if you see here, what is this linear regression? This is a class linear regression. So it consists of all the features of linear regression. So here, what we are doing, we are creating an object with the name model. Okay, so what we are doing, we are creating an object with the name model. Okay, so but as if you see, this model has not yet learned anything. Okay, so this model has not yet learned anything. So what is this exactly? As if now we had created an empty linear regression model. We had created an empty linear regression. It is not doing anything as if. So now what we are going to do is the next step. Come here. The next step. Model dot fit. So now what we are doing, we are training the model using the training data set. Fit. Correct. So the name model is not defined because we have not run this model equal to linear regression. Correct. So now it is executable. Okay. So what is happening? Model dot fit x train comma y train. So this is one of the important lines in the entire program, guys. What is this line? This line model dot fit x underscore train, y underscore test is an important lines in the entire program. So what is this fit means? Okay. So fit means what it is doing, it is learning the relationship between x train and y train. So what it is doing, it is learning the relationship between x train and y train. So x train, if you see, x train consists of overs, wickets, runs, run rate, batting team, bowling team, and Y train consists score. If you go and see Y train, so this is Y train. Y train consists of the score. Okay. So because there are multiple independent variables, the regression equation conceptually looks like this. Okay. So how it will be, how the equation looks like. So already I told you. So the equation will looks like this. When we have multiple linear regression, if you observe, yesterday also. So y equal to beta naught plus b1x plus b2x plus b3x, something like that. Okay, so if you add a b3x, b2x plus b3x. Okay, so what is this y? Y is predicted output. That is dependent variable. What is this x? Okay, x is independent variable. So b1x, b2x2, b2x3. So what is this b naught? B naught is the slope or coefficient. Okay, so generally it will be the same b1, b1 and all. So what is this x1, x2, x3? They are independent variables. So x1 overs, x2 wickets, x3 run rate, and so on. Okay, so those are the things, guys. So what it is doing, it is checking for this particular line, and it is doing the predictions. Okay, so during model dot fit, linear regression estimates. Okay, so what it will do, what this model dot fit will do during this model dot fit only, the linear regression will estimate the coefficient values for the training data. So it will estimate the coefficient values for the training data. And next, come here. Let us make the predictions using testing data. So why predict? Come here. Y predict equal to model dot predict X test. So what is this code? What is this code doing? Y underscore predict equal to model dot predict. So if you see Y underscore predict, let me run that one because I had not run that one. So if you see Y underscore predict, this is Y underscore predict. X underscore test. Okay, so this is X underscore test. Okay. Now let me take Y underscore test also. Like that. So this is Y underscore test. Okay. So for a given 40 overs, 4 wickets, 250 runs, well, run rate is 6.25 when India is bowling first and India is bowling first. That time, India has scored 250 runs. And when 20 overs were bowled, 2 wickets were lost, 150 runs were made, run rate is 7.5. When India is batting first and India is bowling second, that time India scored 340. But what our model is predicting? Our model is predicting that India will score a runs of 290, but actual score is 250. And our model is predicting India will score a runs of 315, but actually that day India has scored 340 runs. Okay. So what it is doing, it is comparing what is the original value in the data set and what is the predicted values. From here, we get the errors, mean square error. So yesterday I told you in the last session, like mean squared errors. So what is mean squared errors? So actual minus predicted errors. Okay. So how you get this actual and predicted errors? So come here, go to the code. So this is the one which is used to evaluate the model case. Okay, mean square error and R square. So this. So mean square. So how will get this mean square error? Actual plus predicted. So actual is think that actual is 250, predicted is 290. The difference is 40. So what we have to do? Square root of 40. Square of 40 we have to find out. And then what is actual? 340 is the actual. Predicted is 350. Okay. So MSC. So mean squared error. Okay. So it is around 125 by 2. So it comes around 62.5, something like that. And again, R square equal to R square, Y test, comma, Y predict. Okay. So this is another thing, R square. Okay. So what we are doing here, we are getting this mean square and R square also. So run that one. Now try to print the evaluate results. So what I'm doing here, I'm printing the evaluate results. So what is the MSC, what is the mean square error, what is R square score. I'm printing the intercept and I'm printing the coefficients also. Okay, so the slope, whatever there it is, if you see here. So let me explain you here. So this is y-axis, this is x-axis. Okay, so y-axis and x-axis. If you see here, what is this? This in this x-axis, we have our dependent variable. Example in this y-axis. So consider we got a line like this. Okay. So actually the points are somewhere like this. So what we are doing, we are finding out the difference, the mean square difference. And then again, we are finding the R square score. Okay. So what is exactly R square score, guys? So tell me, I had told you what is the R square? What is the fund of linear regression? So R square, the line with the highest R square is used as predictions. That is what I we had told you and I had discussed with you in the previous session. So the line which has highest R square value is the line which is used for prediction. So R square coefficient of determination, coefficient of determination. Okay. So what is this R square? It measures, it measures how much of the variation, how much of the variation in the target is explained by the model. So relative to a simple mean based baseline. Okay. So if you see here, it is how much variation is there between actual and all target variable. It is if R square, if our R square is close to 1, or R square is close to 1, that means strong fit line it is. Okay. Suppose if R square is around 0, okay, so little improvement is needed. Over prediction, the mean, over the prediction. Okay, so when R square is close to 1, it is a strong fit line. When R square is 0, that means we need to do improvement. And if you see, R square can even be negative on evaluation data. Sometimes you may get negative also. So when we get R square negative, what is the thing that is performance is worst? Is worse. That is not good. It's not good performance. Okay. So literally, what this R square is doing is R square tells us like how good the best fit line is based upon the measure of R square, whether it is close to 1 or whether it is around 0 or whether it is a negative one. Okay, so based upon the task square, we can tell how much our model is fit. So now here, what we are doing is we will calculate what is the mean square errors and then what is the R square and other things. Yeah, that one. See, these are our values. So mean square error is around 1010. R square score is 0.45, guys. Okay, it is okay. Our model is fine. So this is the intercept where the line meets the y-axis and these are the coefficients. Okay, so coefficients values for different independent variables. Like this is coefficient value for overs, for wickets, for run rate, and all those things. So if you see for run rate, we get a negative coefficients. That means as the number of wickets are falling, the run rate is going down. That means there is a negative correlation here. Okay. So somehow this is our story. And it's also depends upon bowling also. Sometimes if you are bowling first, there are chances of you losing the match. So then again here it is showing the negative coefficients. Okay, so that's the one way to think of it. Okay, now what shall we do is we shall have a let us write a function for user inputs and predict the score. Okay, so for that one, I'm writing a function, guys. So what is this function? Def predict underscore score. overs, wickets, runs, run rate, batting, bowling team. So these are the things to enter: overs, wickets, runs, run rate. And here try block is there, exception block. Okay. And next we are here. These are the inputs that we are giving, and we are getting some values. Let me run that function. Run this. See here, if you observe, here it is asking enter the number of overs bowled. Because if you see here, what are the independent variables? These are the independent overs, wickets, runs, run rate, bowling team, or batting and all. So using this, what we are doing, we are doing the prediction. What is the prediction? The score prediction we are doing. Okay. So come here. So for suppose I am writing, so 10 overs were bowled and how many wickets were lost. Think that we had lost 2 wickets. And what is the scorecard? Okay, so I am entering score as maybe 60 runs. So what is the current run rate? 60 runs in 10 overs. What is the run rate, guys? What will be the run rate? 6, right? Yes or no? Can
Yes.
anyone calculate and tell me?
Yes, sir.
Yes,
Yes,
sir.
it is 6, I guess. And so think that we are batting first. Batting first means 1. So we are bowling, not bowling first. That means 0. Enter. So based upon the inputs I had given, what it is predicting that India will score a runs of 289. Okay, so based upon the inputs, what it is saying, India will score a runs of 289. Okay. So now let us run this again. Okay. So this time we give the same data. Let us give the same data. How many overs were bowled? 10 overs were bowled. Loss of wickets 2. Runs scored for so far 60. Run rate 6. Whether India is batting first. So this time what I will do is India is second batting. Let me see how many runs it will score. So now what it is saying, India will score a runs of 268. That means if India bats first, it will score 280 plus runs. And if India is going to bat second, it can score only up till 268. So that means if the opponent is Australia or something like that, so India will not reach to their score. So that means India will lose the match on that day. So something like that to analyze. Okay. So this is the thing, guys. So now, so this is about the multiple linear regression. So in the last session, we had discussed simple linear regression, a salary and an experience thing. And today we had discussed regarding multiple linear regression, where we have one dependent variable, that is score, and multiple independent variables like overs scored, wickets, runs scored, and other things, guys. Okay. So thank you.